Hi everyone, welcome to our first pre-algebra lesson. Today we'll be going over the concept of integers. So first off, what are integers? So integers are defined as whole numbers, and they are not fractions. I'll give you a few examples. So integers include the numbers -2, 1, 99, and even 0. Some examples of what are not integers include 1/2, -3/4, 0.7, and radical 2. So anything that results in a decimal or a fraction are not integers. Today we'll be going over how to add and subtract integers. So adding and subtracting may seem like a simple concept. You can do things like 2 plus 3 like second nature. You know that's 5. However, when you get stuck, you might want to use a number line. So here's our number line. And when you add integers, you would go to the right of the number line. When you go to the left. It is easy to use number lines when you're using bigger numbers that might be a little hard for you to add or subtract. Let's go over a few examples. Starting with addition, let's do 6 plus 7. So first we draw our number line, and then you plot the first number. In this case is 6. Now the reason why I put 6 to further left of the number line is because when we're adding, as I mentioned before, you move to the right. So for this equation, we're going to the right 7 times. 1, 2, 3, 4, 5, 6, 7. So that's going to be 7, 8, 9, 10, 11, 12, 13. Therefore, 6 plus 7 equals 13. And that's our answer. Let's do more. 4 plus 5. So first we draw our number line, plot the number 4, and because it is addition, we are moving to the right 5 times. 1, 2, 3, 4, 5. And that's 5, 6, 7, 8, 9. So 4 plus 5 is equal to 9. The next one is 12 plus 2. As always, we draw our number line, plot the number 12, and we move to the right 2 times. 1, 2, that's 13, 14. So 12 plus 2 is equal to 14. Now let's try a few different numbers. What happens when you start with a negative number? For example, -11 plus 3. So as always, we'll still draw our number line. But in fact, having a negative number go first does not change anything because we are still doing addition. So that means we are moving to the right of the number line. So let's just plot -11, and we're moving to the right 3 times. 1, 2, 3. And that's going to be -10, -9, -8. So -11 plus 3 is -8. Let's do one more. -4 plus 6. So draw our number line, plot -4, and we add it 6 times. 1, 2, 3, 4, 5, 6. -3, -2, -1, 0, 1, 2. Our answer here is 2. Now, you might have noticed that addition and subtraction are really so similar because let's use the problem that we just did, -4 plus 6. If we just swap these around, it becomes 6 minus 4. These are, in fact, the same exact equation, just rearranged. And let's prove that these are the same. So moving on with subtraction, we're going to plot 6 further to the right because now we are moving to the left since our operation has changed. So we go to the left 4 times. 1, 2, 3, 4. And that's 5, 4, 3, 2. So our answer is 2. And you can see that we got the same answer here as we did just now. Let's do more. 10 minus 4. Draw our number line, plot 10, and move to the left 4 times. 1, 2, 3, 4. And that's 9, 8, 7, 6. Our answer here is 6. (13 minus 9). We draw our number line again, plot 13, and move to the left 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's 12, 11, 10, 9, 8, 7, 6, 5, 4. So 13 minus 9 is equal to 4. Now, as I mentioned earlier, addition and subtraction are very similar, and so you could use the other operation to check your answer. So let's try 4 plus 9. So you plot the number 4 and move to the right 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. And as you can see here, we got the same answer both times. How about 7 minus 4? Plot the number 7, move to the left 4 times. 1, 2, 3, 4. 7 minus 4 is equal to 3. Now, let's try an equation that results in a negative number. So, 3 minus 6. It's still the same routine. Draw the number line, plot your first number, and move to the left 6 times. 1, 2, 3, 4, 5, 6. Our answer here is -3. And you always need to remember that moving to the left means decreasing, and moving to the right is increasing. And that can be clearly depicted by this number line. Let's start using more negative numbers. -5 minus 3. Draw your number line, plot -5, and move to the left 3 times. 1, 2, 3. So -5 minus 3 is -8. How about -11 minus 1? Plot -11 and move to the left just 1 time, and that would be -12. Hopefully through these examples you are able to grasp the concept of adding and subtracting integers. But now, what would happen if you saw something like this? 2 minus -3. As you can see here, there's 2 different signs, and that can be confusing. So what this really means is that when there's 2 of the same sign that are right next to each other, that's just a positive sign. If there's 2 signs that are different from each other, like 2 minus +3, that means it's a negative. So this equation in reality is just 2 plus 3. And this equation is simply 2 minus 3. Now, if this is confusing to you, we'll go more into depth with this later when we are talking about multiplying and dividing. So let's get into multiplication first. When you're multiplying, there may be different signs that you see when people are doing multiplication. These are just a few of the connotations that you can use for multiplication. First is like the X sign. There's also a dot that you can use, and then parentheses. You can also use parentheses like this. Just make sure you know that these all mean the same thing. And just a little disclaimer, when you're using the dot like this, make sure it is not too far down so that it's not mistaken as a decimal point. So let's go over the rules. When you're multiplying, negative and positive signs are very important. Our first rule is that positive times a positive equals positive. Negative times negative equals positive. Positive times negative equals negative, and negative times positive is also negative. To make it more simple, just remember that if there's 2 of the same signs, then it is positive. If there's 2 different signs, that is negative. This might be easier to see with numbers, so let me just show you a quick example. So our rule number 1 was that positive times positive equals positive. So positive 2 times positive 2 would equal positive 4. Rule number 2 was negative times negative equals negative. So So negative 2 times negative 2 is equal to positive 4. As you can see here, same signs always equals positive. Our third rule was that positive 2 times negative 2 equals negative 4. And our fourth rule was just the opposite. Negative 2 times positive 2 equals negative 4. So for these last 2 rules, positive times negative equals negative, or vice versa. So let's try out a few examples. Let's do 3 times 5. So we all know that 3 times 5 is 15. And when we're usually doing regular math, you don't need to put the positive signs. But for the sake of learning the concept, I'm just going to put a plus sign in front of each of the numbers. So here we have 2 positives, and that equals a positive. So positive 3 times positive 5 equals positive 15. Another one would be positive 4 times negative 6. So let's just do 4 times 6 first, which we know is 24. But there's a positive sign and a negative sign, which means that the answer will be negative. The answer is negative 24. How about 2 times 7? This is the same as the first problem. 2 positive equals a positive answer. And let's do negative 5 times negative 4. And because there's 2 of the same sign, that means the answer is positive. And this concept explains why the addition from earlier was how it is. So just to refresh our memory, the example that I gave was 2 minus negative 3. And I said that was equal to 2 plus 3. And that's because you're actually multiplying these two signs. And the multiplication rule states that a negative times negative equals a positive. And so that also explains why 2 minus positive 3 was equal to 2 minus 3, because a negative times a positive, we said, is equal to negative. Now, similar rules apply for division. First, let's go over the different signs that we can use for division. So in math, there's always multiple connotations that you can use to express an operation. So for division, some of them include 15 divided by 3 equals 5. So this funky sign right here is division. 15 divided by 3 equals 5. And this fraction form is also division. And some people like to rewrite that as 15/3 equals 5. So just keep in mind that these are all the same. So let's do a few examples for dividing integers. 49. Actually, before we get into that, the same multiplication rules apply for division when you're working with negative and positive signs. So our first rule is that positive divided by positive is equal to positive. That's the same as multiplication. Negative divided by negative is also equal to positive. And you guessed it, positive divided by negative is equal to negative, and negative divided by positive is equal to negative. What does that look with numbers? 2 Positive 2 divided by positive 2 is equal to positive 1. Negative 2 divided by negative 2 is equal to positive 1, And then negative 2 divided by positive 2 is negative 1. And positive 2 divided by negative 2 is equal to negative 1. Let's do a few examples with dividing them. So 49 divided by negative 7. So we know that 49 divided by 7 is equal to 7. But when there is one positive sign and one negative sign, that makes the answer negative. So our answer is negative 7. How about 45 divided by 5? As I mentioned earlier, you don't need to write in positive signs when you're doing actual math. So these are both positive integers, and that would equal in a positive answer. So our answer here is just positive 9. Likewise, we're going to do two negative signs. So negative 36 divided by negative 6 is equal to positive 6 because it's two of the same signs. Let's do negative 12 divided by 4. And that's two different signs, a positive and a negative. So our result is negative. Now, let's go over the concept of 0. You might be wondering, is 0 positive or is it negative? The answer is actually that it is neither. It is the direct middle point that splits positive signs from negative signs. Let's do some equations with 0. Would be positive 2 times 0. So because the integer you are multiplying with is positive, you would think that the answer would be positive. But no, anything that you multiply with 0 is just simply 0. So 100 times 0 is 0. 1 million times 0 is 0. And 0 times 0 is 0. Does this work with division? The answer is yes, but it works a little differently. So 0 divided by 3 is equal to 0, and 0 divided by 200 is equal to 0. All these large numbers are equal to 0. But we need to be careful here because you cannot divide anything by 0. So swapping this equation around would not work. 300 divided by 0 is said to be undefined. This can be a little confusing concept, but you just need to remember that there's no way that you can divide anything into 0 parts. So our answer is always going to be undefined when 0 is in the denominator. So the most important concepts that we need to take away from today's lesson is when you're using a number line, the right side is adding and the left side is subtracting. This is an important skill to master because when you get confused with larger numbers, like in the hundreds or the thousands, it's easy to use a number line and get the result. Our next most important thing is that the rules with the negative and positive signs. So let's just review them really quickly. Positive times positive is positive. Negative times negative is also positive. Positive times negative equals negative. And negative times positive equals negative. And the same rules apply with division. If you divide these, you get the same results. And you always need to keep in mind that anything divided by 0 is not possible. This is undefined. But you can do 0 divided by any number, and that would equal 0. That's all we have for today. Thank you for listening to the lesson, and if you have any questions, make sure to comment them down below and any feedback you would like to give, and we'll see you at our next lesson. Thank you.